All right. Welcome to the Open Source Data Stack event. This is our first event since our conference in September. We got such a good response from that conference and people enjoying leaning into how people are building open source data stacks that we decided to have some events. So we'll be doing webinars with people and companies showing off the things that they've built. Welcome. Today we have the team from Tapestry project that built a data stack with several open source tools, and they'll be here to present. Feel free to use the Q&A feature of the webinar to ask questions. If they're simple, the team will answer them quickly. If they're more to talk about, we'll leave it till the end and we'll give a full rundown to answer all of your questions. With that, I'll send it over to Katherine from the Tapestry team to present more about their project.
Thanks, Brian. I'm going to go ahead and share my screen once. I think you have to stop. Yeah, great. Hey, everybody. My name is Katherine. As Brian mentioned, I'm here with my teammates from this project, Leah and Adam. Rick couldn't be here with us today, unfortunately. We built Tapestry at the end of last summer over a few months or a couple of months as a fully remote team. So what exactly is Tapestry? It's an open source data pipeline orchestration framework for user entity data. Essentially, we developed Tapestry as a team while we were students in the capstone program at Launch School, as Brian mentioned. It's a CLI tool for creating a simple user data pipeline. So when you use Tapestry, your data pipeline is automatically deployed and ready to ingest data from all your user data sources, store and transform that data in a data warehouse, and sync that data back to your data tools for immediate use. So when thinking about this project, since we were working as students, we had a use case in mind for such a tool and what problem we were trying to solve. So I'm going to start by talking a little bit about that. So let's say there's a hypothetical company we called Rainshield with a thriving e-commerce store selling umbrellas. Rainshield has raised funding and is growing. And as is common in this scenario, departments are expanding to manage the influx of business. And as the business evolves and Rainshield begins to utilize various SaaS tools in order to engage with their user base in new ways and to meet their daily operational needs, they began to experience SaaS bloat. So for example, they might use Stripe to handle all their online transactions. The sales team starts using Salesforce to organize and track leads. And the customer support team might start incorporating Zendesk, for example, to manage their support tickets. The marketing team might be planning on hosting a Zoom webinar such as this, and the list can go on and on. The problem with this is data is becoming scattered across different tools each team's using, and it's becoming challenging to have a unified understanding of users and how they're interacting with a product. And on top of that, to leverage that data. Data is existing in silos. It's going in, but not going out. So take, for example, a Rainshield customer. Let's call her Susy. It might show in Salesforce that she's purchased 6 umbrellas for her friends and families. In Zendesk, we might see that she's called 2 times complaining about the color of her umbrellas. And she also might have signed up for that Zoom webinar. But when this data about Susy lives in different tools, it becomes a big challenge to access a composite picture of Susy. And it's easy to see how this concept can expand to a broader understanding of users and user data. And when all this data can be collected in one place, a company can begin to see patterns and act on these insights. And when you think about how important it is to have a complete picture of your users, you realize just how critical it is for a company to integrate user data from every source in order to operate effectively. So how can a company like Rainshield put all these pieces together for all their customers? And even if they are able to gather this user data for analysis into one place, how are they going to use these insights to impact day-to-day operations or operationalize this data? For example, say Rainshield wants to send an intercom message to users with a particular profile based on their aggregate data. In other words, making insights actionable still requires work. Rainshield has to map relevant user data to intercom in the particular format that intercom requires. This can be thought of as data syncing. So in looking at this type of use case, we then took a step back at the obstacles that Rainshield and other companies like it are facing. User data is being trapped in silos, especially as the quantity of SaaS tools increases. They'd like to aggregate data from these disparate third-party sources into one location for better analysis. And on top of that, they want to sync data to other third-party destinations to drive operations based on their findings. So when considering the challenges of this type of data integration, you have to think about how user data is stored. User data is stored in SaaS applications in a similar structure to the way we see it stored in traditional relational databases. However, data in SaaS applications cannot be accessed with a simple query. Instead, it has to be accessed via unique REST APIs that make it more difficult to communicate with each tool. Further, factors such as limited documentation, rate limits on those API requests, managing potential network errors, and changing API schemas can make transporting large amounts of data a challenging and slow process. So before we arrived at our solution of creating an end-to-end data pipeline, we considered some other existing solutions for this sort of data integration problem. So I'm going to walk through a few of those. And we came up with 4 main options for arriving at the desired outcome. You could manually move files between tools. You could use pre-built connectors. You could create your own custom connectors, or you could build a complete data pipeline. So let's briefly discuss each of these in turn. Manually moving files, the idea of that would be simply exporting a CSV file from, say, Zoom to Salesforce. But this can quickly become tedious if you have to do it often. Another possibility would be to use a company that creates these connectors for you, like Zapier, or even to use a pre-built connection that exists in certain tool settings. However, this type of approach can be limited in terms of what type of data you share, and it's easier to end up with duplicate data. You might also not find pre-built connectors for every pair of tools or the exact use case you're looking for. Another course of action could be to designate a couple software engineers to begin building custom connections to pipe data directly into all of the tools they use. The benefit of this option is you can flexibly choose what data to extract and sync. However, not only would they have to research these tools' APIs to extract data, but also to sync data as well. And this wouldn't be too bad if the number of tools was small, like say the 3 here, but it can quickly get out of hand. And if one API changed, it would need to be altered for all the other tools trying to use it. And the reality is that even small companies these days use anywhere between 10 to 50 tools. And so that would require a lot of engineering time that could be spent elsewhere. So then we arrived at what we felt was the best and most complete solution to this integration problem, implementing an end-to-end user data pipeline with a cloud data warehouse at the center. From an engineering perspective, this approach allows access to data ingestion and syncing tools that remove the headache of working with third-party APIs, while also providing you with the flexibility that custom connectors offer. In other words, you choose exactly what data to send. Placing a cloud data warehouse at the center of your pipeline also provides several other benefits. The warehouse allows for the storage of large amounts of data with very little infrastructure management and instant scalability. Warehouses can also serve as the single source of truth if 2 departments ever have conflicting data. And data modeling and analytics tools can be built on top of the warehouse and can aid in making important business intelligence decisions. Last, the warehouse offers the ability to combine and filter data from multiple sources in order to sync with another destination. This warehouse-centric pipeline helps aggregate all of your data into one accessible place so you can create unified models and sync them to the tools you need. A business like Rainshield can rely on a single pipeline for both analytics and operations to better understand and leverage user data. So when deploying this type of user data pipeline, we found that the two primary options that existed were to use a proprietary hosted solution, such as one offered by the company RudderStack, or to use open source tools to configure your own pipeline. The DIY option allows for the inclusion of fully open source tools, which allows you to see the source code. This openness also means that you can debug problems faster rather than being reliant on possibly unhelpful error messages and sparse documentation. Open source applications can also be a huge learning tool, as it was the case for students like us, and contribute to better software because knowledge is shared. Another point in favor of the self-hosted solution is it grants you full ownership over your pipeline infrastructure, which means you can continue to customize it any way that you like. On the other hand, proprietary pipeline solutions require you to use their infrastructure, leaving you with little control. However, one benefit of a proprietary solution is that it tends to offer many out-of-the-box features, whereas a self-hosted solution would have none. Another advantage of a proprietary solution over a do-it-yourself approach is a big one. A solution such as this abstracts away infrastructure provisioning and management, making it extremely easy to deploy a user data pipeline quickly. In contrast, building your own pipeline requires an extraordinary amount of time and effort to set up, provision, and configure. You have to make a lot of decisions about what tools to use for data ingestion, syncing, which warehouse to select, and that is not to even to mention all that goes into provisioning and maintaining pipeline infrastructure. It can be a pretty complex process. So that's why we built Tapestry, to kind of live in this in-between space. We weave together all of the necessary resources to create an end-to-end user data pipeline by automating the setup and configuration. But Tapestry is for developers who want full control over their data infrastructure without having to provision that initial infrastructure themselves. It's a completely open source framework that automates the entire pipeline deployment process. However, there are not many out-of-the-box features beyond that. To get a better idea of the process that Tapestry automates, we have a chart here kind of outlining the steps and automated and the resources created for each phase of the pipeline deployment. As you can see, deploying your own user data pipeline would require at least 71 steps and the provisioning of 49 resources between AWS and the data warehouse. I'm going to hand it over to Leah now to see Tapestry in action for an end-to-end demo.
Thanks, Katherine. Getting started with Tapestry is pretty simple. If you are the engineer looking to get started, you would first need Node and npm installed on your local machine, as Tapestry is a Node package. Also, since Tapestry is specifically configured to set up a number of AWS resources for you, you also need an AWS account and the AWS command line interface set up and installed on your machine also. Finally, users will also need to have a Docker account and have that set up on their machines too. After these first few steps, all you need to do next is to run the npm install Tapestry Pipeline command with a global flag, and then a host of other commands and options will be given to you. So as a new user, the first Tapestry command that you would run next is Tapestry init. With init, you choose a project name for yourself, and then Tapestry will give you all of the needed project folders and an AWS CloudFormation template, which will be used to provision, and configure AWS resources with code. This specific template is used to create resources for the data ingestion phase of the pipeline. After running this first command, the command that you pick next will actually determine what resources Tapestry will give you next in order to set up your data syncing phase of the pipeline. So now you have to pick between our deploy and kickstart commands. Once you make this choice, Tapestry will then give you all of the necessary configuration files for the data syncing phase. Both commands automate the deployment of a fully operational pipeline, but kickstart also includes 2 pre-configured sources, Zoom and Salesforce, along with one destination, MailChimp. These pre-configured third-party tools set up your pipeline to have immediate end-to-end data flow, beginning with data ingestion and ending with data syncing back into these tools. To better show the full flow of data through our pipeline, we will demonstrate our kickstart command. So prior to execution, you will also need to set up accounts for Zoom, Salesforce, and MailChimp. Kickstart then begins by prompting you the short series of questions about the previously mentioned accounts, as well as Snowflake, Tapestry's data warehouse of choice. After information has been collected, Kickstart continues by creating the necessary databases and tables within your data warehouse to be utilized by both your ingestion and syncing tools. Let's take a peek under the hood at the actual infrastructure that this command is provisioning. Tapestry uses the CloudFormation template supplied during the init command to create a CloudFormation stack, provisioning AWS resources specifically related to your ingestion tool, such as an S3 staging bucket, an EC2 instance for the tool to run on, and an application load balancer to route traffic to that EC2 instance. The ingestion tool is then configured to extract certain data from your Zoom and Salesforce accounts and send it over to your data warehouse. You will then be asked to carry out a few more steps so that the data is transformed within your warehouse using a data model that Tapestry gives you. Essentially, the data will be aggregated from both sources into one table, filtered for duplicates, and appropriately formatted to be synced to MailChimp. To complete the pipeline, Kickstart creates another CloudFormation stack, this time spinning up various AWS resources for your syncing tool, such as an Elastic Container Services cluster, which is used to properly run your syncing tool's application, and one more application load balancer to route network traffic to that cluster. If you are setting up a brand new pipeline, Tapestry automatically launches your own Tapestry Dashboard. This dashboard contains documentation for how to use Tapestry, along with various pages relating to each section of your pipeline. Each page shows you metrics that give you better insight into the health of each component. Some of the pages for each tool will show things like data logs, CPU utilization, the amount of data sources that tool is using. All of these dashboard links also include, all of these dashboard pages also include links to the tools themselves or documentation. So after your pipeline is all set up, after running the kickstart commands, let's just start off with a quick example of how this pipeline will work. Let's say that we had two lists of customers. One was from a Zoom webinar, while the other list had customers from Salesforce who had purchased an umbrella in the past. By transforming data within the Snowflake warehouse, we're able to filter for duplicates and combine data into one table to be able to reconcile the differences in this data, and then finally be able to sync that data back into another third-party tool. For example, we have MailChimp here. Now that we know how Tapestry works, let's explain how we built it. Before diving back into the specifics of Tapestry's architecture, let's quickly revisit the 3 phases of our pipeline: data ingestion, storage and transformation, and syncing. The ingestion phase is where data is extracted from various sources and then is pushed into a data warehouse. Once in the data warehouse, this raw data is stored and is then also available to manipulate or transform it in any way needed. Often transformation is needed in this step so that we can match the final data schema of that third-party tool that we're syncing the data back into. After this data is then synced back into those third-party tools, further actions can then be performed on this data, such as operationalizing it. In the upcoming sections, we will walk through each of these three phases and Tapestry's corresponding architecture. Each of these three next questions helped us when we were researching how to piece together each part of this data pipeline. First thing that we thought about was what is required for this phase. For example, the data syncing phase. The second question that we thought about was what tools should we use for this phase of the data pipeline and why? And then number three, we also thought about how will this part of the pipeline be deployed and automated? Let's start off with data ingestion. An effective data extraction tool will contain and manage a library of API connectors specific to each source. This management of connectors abstracts away the maintenance required to grab data from ever-changing API endpoints. Also, this tool should allow for scheduling data extraction and should also keep track of global state so that only new data is pulled. Now, in order to make this choice regarding data ingestion, it's also important to consider the path by which data travels. Prior to cloud data warehouses, data was transformed and cleaned prior to being stored in a database. This approach is known as extract, transform, load, commonly referred to as ETL. However, with the advent of cloud data warehouses, costs of storing data have decreased dramatically. This makes it more feasible to store all of your user data as raw data and transform the data after it's been loaded into the data warehouse. And since transformations are not required first, data can be loaded extremely fast. This approach is known as extract, load, transform, or ELT. Since it was vital for a pipeline to have access to all of the raw data, we chose to go with an ELT solution. While many data ingestion tools are available, like Fivetran, Stitch, and Meltano, we ultimately went with Airbyte. We liked that it was open source, had standardized API connectors, a robust user interface, and strong community support. Using Airbyte, we were able to extract raw data from many third-party tools through its library of managed API wrappers, covering the E and L of ELT. Both the Airbyte application itself, as well as each of its connectors, all run on their own individual Docker containers. Airbyte gives you the Docker image to deploy their application. And after that, we configured the data warehouse as a destination for Airbyte via a series of API calls. So essentially, the main application's container needs to be able to generate new containers as users set up more and more connections. Due to this necessity of a Docker container needing the ability to create other Docker containers, Airbyte recommends the use of an AWS EC2 instance as a virtual private server for hosting. While we prefer to use a container orchestration service to horizontally scale the computing resources used by each container, an EC2 instance still allows for vertical scaling of the entire instance. Finally, we placed an application load balancer in front of Airbyte, which means that traffic cannot reach the EC2 instance directly. This allows us to take advantage of the security measures that AWS gives specifically to its application load balancers, such as protection from port scanning attacks and protection from DDoS attacks. It also means that the actual address of the EC2 instance is hidden since it's protected by that application load balancer. While prototyping the ingestion part of our pipeline, we also did encounter an interesting challenge. Initially, all of our Zoom data was being extracted and loaded into our warehouse without any issues. But our Salesforce data was consistently timing out, eventually leading to a 504 server error. In AWS, we saw that our Airbyte EC2 instance was becoming an unhealthy target for application load balancer every time we attempted to sync with Salesforce. So we dug a little further and found ourselves in the AWS monitoring dashboard looking for clues, mostly about our AWS resources use. Then we noticed that our CPU usage was through the roof. This led us to believe that the size of the EC2 instance may be the root of the problem. So we vertically scaled our instance and our error message disappeared. This also led us to include a CPU usage section on our Tapestry dashboard to monitor our AWS resources, as shown before in our demo. Now I'll pass it over to Adam, who will cover the rest of Tapestry's architecture.
Thanks, Leah. So the next phase of our data pipeline is data storage and transformation. And let's see. I'll start talking about data storage first. So we've already determined that at the center of our pipeline should be a warehouse that is capable of handling large amounts of data from a variety of different sources. And given our decision to host our tools on AWS services, we also wanted a warehouse that could be seamlessly integrated with AWS. So while there are many options for a data warehouse, we chose Snowflake. Snowflake can be built on most major cloud platforms, providing valuable flexibility. It also separates storage needs from query processing, also known as computing. And this allows companies to take advantage of cost savings, as well as enable us to scale those two responsibilities independently. Finally, Snowflake abstracts away the provisioning and maintenance of all necessary resources for a cloud data warehouse. Now, initially, we attempted to load data directly into Snowflake from third-party tools. But we found that the data transfer was really slow. And that led us to investigate using a staging area with Snowflake. Without the staging area, Airbyte was only able to insert one row of data at a time into Snowflake, and that required a ton of SQL insert commands to copy over an entire table. But with the addition of a staging area, Airbyte can achieve efficient bulk data loading. And so in order to implement this staging area, we provisioned an Amazon S3 staging bucket between our Airbyte instance and Snowflake. Now, one interesting challenge that we ran into when we were working with Snowflake was how to run SQL commands for a new user once we had their credentials. We needed to run a sequence of 34 commands in order to set up the warehouse with the necessary databases, schema, roles, and permissions for the Tapestry pipeline to operate. And we found that Snowflake provides a Node.js SDK. But since the SDK only allows one SQL statement to be executed at a time, we needed to store each statement as an array element and then iterate through each one individually. But now that we can execute each SQL statement individually, we ran into another problem because the SDK is callback-based and runs code asynchronously. So to visualize this problem, we added a log statement with the array index, and you can see how the statements are being executed out of order here. Basically, our error logs indicated that Snowflake was attempting to create databases and tables before the permission and role statements had finished executing. So we opted to use the Snowflake Promise library, which is just a wrapper for the Snowflake SDK, but it provided us with a promise-based API. And this made it possible to use async await to handle multiple promises synchronously, as you can now see by the logs. Okay, so now let's talk about the other half of this phase, data transformation. We wanted a data transformation tool that was flexible and could transform data to meet a variety of both analytical and operational needs. Ideally, we wanted a SQL-based data transformation tool that could be utilized by non-developers to create data models based on the warehouse and then put that data into action more quickly. And finally, we wanted a tool that maintains a history of all of our data transformations, because documentation about our data models and how they relate to each other provides better context for how data has been manipulated over time. So when considering all of these requirements for a transformation tool, one option stood out because it encompassed all the features that we wanted. It was free and open source, and that tool was DBT, or Data Build Tool. Now, as previously seen in our demo, DBT can be used to aggregate data and handle duplicate entries. Other transformations you might want to perform include changing column names and copying only the particular fields over from one table into a new table. And since DBT has its own cloud version, Tapestry doesn't need to provision any resources for it. So we opted to go with the cloud version of DBT because of its ease of use and simple to understand UI. And that brings us to the last phase of our pipeline, data syncing. This is where we send data back into external tools that can then take some sort of action on that data. So much like data ingestion, this requires a library of API connectors specific to each destination. And we wanted the ability to schedule when to transfer our data. But data syncing is more challenging than ingestion in that the data must conform to the destination schema. And so this concept of syncing data back into your tools, which is relatively new, has recently been coined reverse ETL. Now, if you recall, ETL and ELT are concerned with moving data from your tools into your warehouse. And reverse ETL moves data out of your warehouse and back into your business's operational tools. So this term reverse ETL, which is becoming pretty common, can be a little bit confusing. And so that's why we prefer the term data syncing. While proprietary tools exist in the data syncing space, like Census and HighTouch, we opted to find one that was open source. Grouparoo is just such a tool, does everything that we need, and they have a kangaroo logo to boot, making them an easy pick. Grouparoo recommends deploying their web application stack with an application layer and a data layer. I'll talk about the application layer first. This is where a worker server and web server will reside. So when a request to sync data up with external sources comes in, it first hits a load balancer, which then directs the request to the web server. From there, the web server can then offload the task to the worker if the task is going to take a long time to complete. With these slower jobs being run in the background, it can improve the responsiveness of the web server. The data layer houses the application database as well as the cache. Grouparoo recommends using Redis to serve as both the cache and also as the background job queue for the worker server. And they also suggest using Postgres as the database where your user data will be stored. Let's take a look next at how this application architecture informed Tapestry's deployment of Grouparoo to the cloud. Given the distributed nature of this architecture, we thought it was appropriate to deploy each component as its own Docker container. This way, Each container would have only one concern, and the decoupling of responsibilities would make it easier to horizontally scale in the future. Group provides a Docker image that can be used for deploying the web and worker service. Starting with their base image, we added the necessary configuration to integrate Snowflake as the data warehouse for Group to use as its primary data source. And a quick note, Group uses JavaScript or JSON files to store config details. And because of that, any configuration changes require the Group Docker image to be rebuilt. So we chose to push the image that we provide to a repository on AWS's Elastic Container Registry, giving the user easy and private access for any future updates. Next, we provide a generic Redis and Postgres Docker image to run the containers for the data layer. Now, since this is a multi-container deployment, we had to consider how best to handle container orchestration. So some popular options include Kubernetes, Docker Swarm, and Amazon Elastic Container Service, or ECS. Kubernetes and Docker Swarm are both highly configurable, but the learning curve is pretty steep. So we decided to go with Amazon ECS for Tapestry's Group deployment because it manages and scales containers efficiently and automatically. This choice also gave us the ability to use the recently rolled out ECS and Docker Compose integration, which simplified the process even more. So the Docker Compose is a tool that allows developers to define and run multi-container applications via a YAML file. And with this integration, we could seamlessly use this same Docker Compose file to deploy the Group application and all its dependencies as an ECS cluster. AWS resources are created automatically based on the specifications in this file. And this works because there are built-in mappings between the Docker containers defined in the file and the ECS tasks. ECS not only manages these containers, but the servers they live on as well. And this occurs via AWS Fargate, a service that abstracts away server provisioning and handles it entirely on the user's behalf. We also placed a load balancer in front of the ECS cluster for the exact same security reasons that we put one in front of our Ingestion tool. And since we use a load balancer, we're set up nicely to horizontally scale in the future if needed. So once Group is deployed, you're ready to start pulling data from your warehouse and syncing it into your other third-party tools, like MailChimp. One particularly interesting challenge that we faced when deploying Group was determining how to inject sensitive user inputs, like API keys or passwords, into the Docker container for Group web application. For Group we needed to reference these inputs in config files as environmental variables. And as we soon learned, you can pass environmental variables to a container by referencing a local.env file in a Docker Compose YAML file. And this solved part of the problem, right? The Docker container could now access any variables we provided in this file. But since we were not receiving the user inputs until runtime, this .env file had to be dynamically generated after these inputs were received via the CLI, but before the container could run on ECS. So our solution was twofold. First, we stored the user inputs in the SSM parameter store on AWS, and this ensured that the sensitive information was secure and encrypted, but also available for us to access from the AWS CLI as needed. Then we created a function to dynamically write the .env file in the user's project folder after we had all of their inputs. Now that we've had an in-depth look at each piece, let's zoom back out to view the pipeline in its entirety. As outlined before, the amount of steps involved in the configuration and deployment of pipelines requires a tremendous amount of time and effort. And that's exactly why we wanted to build Tapestry, to alleviate the pains of pipeline setup for developers and save them valuable time in the long run. We also wanted the management and maintenance of the pipeline to be as easy as possible. So we provide a UI dashboard for monitoring the health of your pipeline and for observability. That being said, there are still a few features we would like to implement in the future. One thing that we'd love to do is enable cross-platform support, such as deployment on Google Cloud Platform. We would also like to deploy Airbyte with ECS so that our user has greater flexibility in terms of scaling. And Airbyte has indicated that this compatibility is coming sometime in the near future. Additionally, we would like to add more built-in templates to the kickstart command so that Tapestry can be used out of the box for more use cases. And lastly, we'd like to add more advanced metrics for pipeline monitoring, such as CloudWatch, alarms that can send notifications when particular utilization thresholds are reached. Now, since we created Tapestry while we were students, and we are all now working engineers, we have not been able to implement any of these new features, and the project is not being actively maintained. It's still available to the general public, but hasn't been updated for several months. And that's Tapestry. Thanks so much for coming out and listening today. At this time, we'd love to answer any questions that you might have, and we'll jump back now to our architecture in case any questions relate to it.
Well, thanks, everyone. One question we see in the Q&A, feel free to ask more, any of the participants, is around the spirit of open source and yet here we are on AWS or GCP or Azure or something like that. Like, are there any options to, like, is it a good idea or a bad idea to do this like all on your own?
We didn't really find a feasible option in terms of kind of the depth and breadth of resources that something like AWS offers. And I guess, in a sense, this project was theoretical. So we also had the sense that a company may already be using something like AWS and have some of their infrastructure resources there as well.
I mean, there's certainly ways that, and companies that host their own servers in-house, and you can even buy like a physical box in a data center and things like that. But these cloud platforms have proven to show a lot of value in general, and you have ownership over your data. So most people that I meet are definitely going in that direction until they've reached a very aggressive scale, like Facebook has their data centers and Google and such. And then I guess rent those out to others in the end is how it works.
Right. And it would be challenging to not have some sort of cost associated with that. Yeah, so for the purposes of the project, we did incur a little bit of cost on AWS, and then for Snowflake, you can do a free trial. So we took advantage of that.
Great, thank you. Any more questions in the Q&A? Thank you. I have one then. Like, you guys did this as a project, and now you've joined new companies. Are you? Is it interest you more in the data movement space? Are you getting involved with those pipelines in your new companies?
Yeah, absolutely. In fact, one of the companies that I joined, they were interested in trying to utilize Tapestry because they were running into similar problems that we described with SaaS Bloat. and they had all of these different tools, but they were having difficulty coordinating all of the data and then actually making the data actionable. So in talks with one of the data engineers at Trust and Will, which is the company that I'm at, trying to get some of it actually implemented.
That's great. Yeah, we're definitely, seeing companies excited about putting that data into action and having that ownership that open source provides. Wonderful. Well, we thank everyone for attending the webinar. This will be available up on the interwebs and back on the opensourcedatastack.com website shortly. And thank you very much. And very excited to hear from anyone that wants to present a data stack that they've built as a project or within their company and show off the technologies that you're using. Thanks, everybody, and have a great day.